everybody, my name is Arya.
And my name is Alice.
From Bach Bros Studio. And today, we're here at the Tandon School of Engineering at NYU to meet with Professor Justin Cappos, who specializes in computer science.
We're so excited. Are you ready?
Let's go! Hello, Professor Cappos, and thank you for making the time to meet with us today.
Well, welcome to my office. Thank you for coming.
What is computer science and how does it relate to everyday kids like us?
So computer science roughly is the way to think about solving problems using repeated tasks. So let's say that you wanted to solve a problem that required something like multiplication. One way you could do that is to add repeatedly. And computing and computer science a lot of times lets you solve big, complicated problems by using very simple principles. So for instance, in the old days, we used to have these things phone book, where it had a list of everybody's phone number and information for businesses. And this book might have 1 million names or something like that in there. And for example, if you start in the very first page to look for somebody's name and you went down the list of all the names, one after another, it would take you a really long time to find everybody's name. But that's not how you use a phone book. It's not how you use a dictionary. What you usually do is you say, oh, well, I want to look up a word that starts with the letter S. And I know where S is in the alphabet. S is a little bit towards the back of the alphabet. So I'm going to roughly open the book up about 2/3 through and then start looking for my word. And if I happen to open it up and I'm in something like an N, then I'm going to jump quite a few pages. And if I open it and I'm already very close to my word with an S, then I'll just move only a couple of pages. And so things like that procedure for figuring out how to use a dictionary, how to do things like that, are things you do all the time without thinking about it. And they're things that we can automate and make computers do efficiently using what are called algorithms. That is the plan for doing these types of things.
So how did you get interested in computer science when you were younger? And what was one fun or surprising project that you did that made you realize that this was the field you wanted to pursue?
So for me, I love computer security. That's the part of computer science I do. But I also very much like to build things. Some computer security people like to break into systems and hack things like you see in some of the movies and stuff like that. I like to make systems that are very hard for other people to hack or to break into. And my mom likes to tell stories of me when I was around your age doing things where she knew I was, had this kind of computer security talent and stuff like this, where, for instance, like one of my friends, their dad had a checkbook for an account that they had closed. And said, oh, I've closed this account. You kids can play with my checkbook. A checkbook is, you write down who you want to pay money to and how much money and so on. And I said, well, that's really interesting, but can't I just go and give these checks out anywhere I want? And how are they going to know that your account was closed? And then my friend's dad thought about it and said, I'm not going to give you my checkbook. It's a good idea. From a technical computing standpoint, I always loved to build things and work on things myself. I was always kind of tinkering and making new things. And I think that is one of the key things as you start to learn how to program, as you start to do these types of things, just always figure out what to make. I like to play Settlers of Catan, a board game, with my wife. And, I made a little program that automates all the dice rolling and does other stuff and tracks statistics about how often people get a 7 and stuff like that, just for my own fun. I'm always making different things to play with new tools and stuff, and that's really how you learn.
So adding on to what you said for making it hard for people to hack, we know that part of your work is making the software safer for the public. So can you briefly explain what that is and also share why it is important?
Sure. One big area that I've done a lot of work in is what we call the software supply chain. And just like if you go to buy, let's say you go to buy a candy bar, the candy bar was made in a factory. And the people working in the factory had to do a bunch of things to make that candy bar safe for you to eat. So they make sure that, there aren't any bad chemicals in it. They make sure there's no glass or any other bad stuff that it would hurt you if you ate it. And surprisingly, the way we make software, the way you make the software that goes on your phone or that's in the car that you drive has software, or all the things around us, a lot of them have software in them. Those kind of factories, those software factories, the way that software is made is not very secure. It's very problematic. And we have incidents, like there even was a big incident last night where there was a company that had very poor protections for the way they were doing it that has caused a fair amount of damage for users. So I've really focused on how do we take the things that most people take for granted, like doing software updates or just building and compiling your code, or other parts of testing and securing that. How do we make it so they're actually provide strong security in practice?
Looking ahead, how do you think computer science will improve in the next few years, especially in areas that will affect the next generation?
Well, computer science has gone through several big changes historically. Back even before, in the time of your grandparents or so, then the way things worked is there were punch cards and big, huge machines where you wouldn't even have a computer in front of you. You'd literally take a piece of paper and punch holes in it and send this off, and then they would tell you what your program did. You'd have to mail it somewhere or have people carry it somewhere and run it. And this moved to a model where there was more of a mainframe with connected terminals, which is like a big computer in a building that has a bunch of places you can log in and type things. And then from there, it moved to everybody having their own PC, okay? Those were all big shifts in how people did things. And then after that really came the internet as a major shift, where people started to do things like you have today, where I can go and be writing programs on my laptop, and with just a click of a button, this all goes and ends up running on some servers that are managed by Google, by IBM, by some other cloud company that's providing this to me. The big change that's happening right now is AI. Before this, AI there wasn't really a good way to automate programming. People have come up with new languages and stuff, programming languages that make it easier to write things in certain ways and stuff like this. But for the most part, programmers have always been something where there's been an increase in demand. And now what we're finding is that a lot of these AI tools and AI programming environments are good at doing work that is done by junior programmers. It's not necessarily at the same level of quality. It's not necessarily all work, but a lot of the work that's boring in writing code can be automated now. And the real question that I don't think anybody knows is how far this is going to be able to go. Because if the automation gets a lot better, then it will be able to kind of automate more and more work and do it better and better. And then we may see that programmer jobs are not as important, and that your way of going and asking program to be written, you could just ask Cursor, or you could ask ChatGPT, or ask one of these things, say, write me a program that looks like this. And if it can do a good job of it, then maybe a lot of the low-level programmer jobs will go away, maybe even some of the mid-level ones. Playing with and being comfortable with it and understanding what's really happening with AI is I think one of the big changes that's happening right now in our field.
So how can university students that major in computer science learn this subject as fast as it develops?
If you imagine that I tell you, hey, there's this new thing called a hammer, there's a question of knowing how to make good hammers or knowing how to use a hammer. And many, many, many more people need to use hammers than need to understand how to make good hammers, right? And understanding how to make the best hammer doesn't make you better at swinging a hammer necessarily, right? With what's happening today, I think that most people need the skills to be able to use the tools in a good way. I do think also that the people who are making the hammers don't really know what they're doing. They're trying things, and sometimes they work, but they often don't know why they work the way they do, which is one of the surprising things about AI. It's not something where we prove a new mathematical theorem and, like we do a new math problem, we say this is going to be 7% better. It's a lot like we try something and then it's 20% better, and we don't know why ahead of time. And this has happened at times in the past where, like making the light bulb, they tried tons and tons of different filaments, like things that go inside of light bulbs to make them shine. They tried hundreds, I think, of those before they finally settled on the thing that was used widely inside of light bulbs. So we're kind of at that stage with AI now. So understanding the rough ideas of it and understanding problems it has and where things can go wrong is really, really important. And if you're going to try to work in AI systems, you need to deeply understand all the math and all the other things with it.
What is one piece of advice you would give to the young generation about computer science and how best we can prepare for it?
Play. Just find something that excites you and play around and build stuff. Don't be afraid to do that. And whenever you encounter something you're not really sure about or is like a stumbling block in it, like, hey, I want to make a little robot that does this, but my robot has this problem, then dig deep and learn why it has that problem. I actually really like to work with undergraduates and even high school students a lot of the time. It's because they don't know what science says is impossible. They just see a problem. Throughout my career, done a lot of things where everyone in the field had said, there's no good way to solve this. Like, we can't solve this problem. We can't do this. We can't do that. And I think if you come at the problems and say, how do I really solve it? You know, if I want to tackle this, is there some approach I can do to address this that people haven't thought of? And then if you do that and you have that willingness to think freely about it, you can do, I think, really impressive things, and you learn a lot. You're able to understand problems in ways that other people don't. Find something that excites you, play around with it, and if you get stuck, don't give up. Look for ways around it. Ask other people for advice.
And there you have it. This conversation shows how anyone can learn more about this exciting field that's all about creating and protecting the tech we use in our everyday lives. Hope it sparks your curiosity to explore more. And for more, please follow us at Bach Bros Studio. See you next time. Bye!